Hello students, we are going to study the velocity and acceleration in component form. We already know about the position and displacement of vector. Try to understand figure. Here we have taken P point and we have just joined OP. So the OP is here position vector and it is denoted by the R. The position vector R of particle P, it is located in plane with reference to the origin of xy reference frame, and we can write the equation for r is x I cap plus y j cap, because you know that I cap is a unit vector along x axis and j cap is a unit vector along y axis. So x and y, these are the components of r along x and y axis. Let us try to understand about the displacement vector. See, here we have taken the P point. You already know about the OP. OP is a vector R. We have taken one more point, that is a P dash, that we are considering OP dash. It is R dash vector. Here we have to find out the displacement. The displacement is what here? Delta R. Here delta R is nothing but R dash minus R, the final position minus initial position. So we can write the equation for delta R. You can see the delta R, it is R dash minus R, and here the displacement is from P to P dash. Here we can write delta R is equals to, we already studied about R. R we can write that is x I cap plus y j cap. Same like that, R dash we can write x dash I cap plus y dash j cap. Obviously delta R will be x dash I cap plus y dash j cap minus x I cap plus y j cap, and here we can write it is nothing but delta x I cap plus delta y j cap. You can observe in figure delta x and delta y, where delta x is nothing but x dash minus x and delta y is nothing but y dash minus y. So the position vector r we can write x I cap plus y j cap, and the displacement delta r we can write here delta x I cap plus delta y j cap. Now let us try to understand about the velocity. That is, you already know the basic formula of velocity, that is the displacement upon time. Here v average, the average velocity we have taken, it is nothing but delta r upon delta t. Now only we have seen delta r is nothing but what? Delta x I cap plus delta y j cap upon delta t. So we have got the formula of v average. We can separate it. We can write delta x upon delta t I cap plus delta y upon delta t j cap. Here we can write the equation for v average. See, delta x upon delta t, it is nothing but what? V in terms of x component, and delta y upon delta t, that is v in terms of y. So we can write this equation for average velocity, that is v average is nothing but vx average I cap plus vy average j cap. So here the direction of v average is the same as that of displacement, is the same as that of delta r. Here you already know the term of instantaneous velocity. Instantaneous velocity means what? The velocity at any instant, that is called the instantaneous velocity. Here the equation for instantaneous velocity is v is equals to limit delta t tends to 0. If you will see here, the limiting value of average velocity as the time interval, it is nearly equals to 0. It is approaches to the 0, and that we can write it is limit delta t tends to 0 delta r upon delta t. It is instantaneous velocity, or we can write v is equals to dr upon dt. So here this equation is related to instantaneous velocity. Now let us try to understand the velocity in component form. For that we have to take x and y axis. We have taken again P point. See here, we have to consider the velocity along x and along y. So you already know about I cap, it is along x axis and j cap is along y axis. So we can write the equation for velocity. Here limit delta t tends to 0 delta r upon delta t. See, we can write delta r upon delta t in terms of x and y, because you can see in figure we have taken here vx I cap vy j cap, and it is nothing but limit delta t tends to 0 delta x upon delta t I cap plus delta y upon delta t j cap. Now we can separate it. We can write limit delta t tends to 0 delta x upon delta t I cap plus limit delta t tends to 0 delta y upon delta t j cap. Here this we can write dx upon dt I cap plus dy upon dt j cap. You already know dx upon dt is nothing but what? Velocity vx, and dy upon dt it is vy. So we can write this equation in a component form, that is v is equals to vx I cap plus vy j cap. It is the component form of velocity. So vx is dx upon dt and vy is dy upon dt. We already studied about the magnitude. Here we can write the magnitude of velocity v is nothing but root of vx square plus vy square. If you want to take 3 axes, this equation will become vx square plus vy square plus vz square. So here we have taken 2 axes. So the magnitude of velocity is v is equals to root of vx square plus vy square. Here the direction of velocity v is, here you can write from figure tan theta, that is vy upon vx. We can write the equation for theta, that is tan inverse of vy upon vx. So we have seen the component form of velocity. Now let us try to understand about the acceleration. The average acceleration of particle is nothing but the ratio of velocity to the corresponding time interval, that is average acceleration is equals to delta v upon delta t. Now only we have seen the velocity is in component form, that is vx I cap plus vy j cap. So we can put it, that is delta vx I cap plus vy j cap upon delta t. Now we can separate it, delta vx upon delta t I cap plus delta vy upon delta t j cap. So we can write it delta v upon delta t, it is nothing but acceleration. For x we can write ax, and for y we can write ay. So the average acceleration, that is a average, it is nothing but ax I cap plus ay j cap. See, now instantaneous acceleration, we already know about instantaneous acceleration. The limiting value of average acceleration as the time interval it is nearly equals to 0, it is approaches 0. We can write the equation for instantaneous acceleration is a is equals to limit delta t tends to 0 delta v upon delta t, and that also we can write a is equals to dv upon dt. Now let us try to understand the component form of acceleration, same like a velocity. Here we have taken the equation a is equals to limit delta t tends to 0 delta v upon delta t. Now we can write the velocity is in component form. You know, we can take it is vx I cap plus vy j cap. So we can write this equation limit delta t tends to 0 delta vx upon delta t I cap plus delta vy upon delta t j cap. We can separate it, limit delta t tends to 0 delta vx upon delta t I cap plus limit delta t tends to 0 delta vy upon delta t j cap. That we can write dvx upon dt I cap plus dvy upon dt j cap. You know that I cap is a unit vector along x axis and j cap is a unit vector along y axis, and delta vx upon delta t, here we have taken limit delta t tends to 0 delta vx upon delta t, that is nothing but dvx upon dt, and limit delta t tends to 0 delta vy upon delta t, it is nothing but dvy upon dt. And that we can write in a component form, that is a is nothing but ax I cap and plus ay j cap, where ax is what? Dvx upon dt, and ay is dvy upon dt. So the acceleration in component form, that is a is equals to ax I cap plus ay j cap. So its magnitude we can write same like a velocity, that is a is equals to root of ax square plus ay square. We can write tan theta same like a velocity, ay upon ax. Theta is nothing but what? Tan inverse of ay upon ax. So now let us try to understand motion in plane with a constant acceleration. We already learned the kinematical equations. You already know the first equation of motion, second equation of motion. Here the velocity of object be v0. It is a initial velocity. It is at a time is 0 at that time, and v at the time means here we have to take v and v0. V is a final velocity and v0 is what? Initial velocity. So you know the formula of acceleration, that is velocity upon time, change in velocity divided by change in time. So the final velocity minus initial velocity, that is v minus v0 divided by t minus 0. We can write the equation for acceleration, that is v minus v0 upon t. Now here if the t, it will be go to this side, the equation we are getting v is equals to v0 plus at, and it is nothing but your first equation of motion. Here we can write this equation in terms of x and y, that is vx is equals to v0x plus axt, and vy is equals to v0y plus ayt. We can write this equation in terms of x and y. Now let us try to understand. Here we have to take the object r0 at a time t0 and r at a time t. Then the displacement, it is nothing but what? You know already, it is a product of average velocity and time interval. So we can take r minus r0, it is a displacement, where r is the final position and r0 is initial position. So r minus r0, it is a displacement, is equals to a product of average velocity and time. Average velocity is what here? V plus v0 divided by 2. Initial velocity plus final velocity divided by 2. It is average velocity, and time interval is what here? T. So if you will simplify it, you can put here the equation v is equals to v0 plus at. Instead of v, we are putting v0 plus at according to first kinematical equation. So you will get here v0 plus at plus v0 divided by 2 into t. So we can simplify it. Here v0 plus v0, you know that 2v0 divided by 2, it is what? v0. See, t is here, so we can write v0t. 80 into t, that is 80 square, and divided by 2, what is we can write? Half 80 square. So r minus r0 is equals to v0t plus half 80 square, and it is nothing but a second kinematical equation, and that equation we can write r is equals to, r0 will go to this side, so r is equals to r0 plus v0t plus half 80 square, and we can write it is in terms of component x is equals to x0 plus v0 xt plus half axt square. Same we can write for a y also. So the motion in plane with a constant acceleration, in that we have seen the first kinematical equation and second kinematical equation, that we can write in terms of component in terms of x and y. Now let us try to understand the relative velocity. We already studied the relative velocity. See, when the velocity of object is measured with respect to an object which is at a rest or in a motion, then the velocity, whatever we are measuring here, this velocity is known as relative velocity. You know already the equations of relative velocity, that is VAB is nothing but VA minus VB, and VBA is nothing but VB minus VA. Now let us try to understand with the help of figure. Here we have taken VA and this is VB. Now try to understand here VB. See here, its direction is opposite, so VA, and we have taken minus VB. It is a negative vector of VB. Now we can write the equation. See the diagram. Observe here. VAB is nothing but what? VA minus VB. We already studied the triangle law of vector addition, and with the help of this also we can write VAB is nothing but VA minus VB. You can observe OP. OP is VA and PR is minus VB. So OR, it is a resultant vector and it is nothing but VAB is equals to VA minus VB. And this is about the relative velocity. We can write the equation mathematically. VAB is equals to VA minus VB, and VBA is nothing but VB minus VA. So we have discussed about the velocity and acceleration in a component form. Next time we will learn projectile motion. Thank you.